Guys, and welcome to my fourth lesson on quadratics. Today we look at something called the discriminant of a quadratic. Now hopefully you've watched my previous video where we looked at the quadratic formula, and that was minus b plus and minus the square root of b squared minus 4ac all over 2a. Now this is the discriminant. This is the part of the quadratic formula within the square root sign, the b squared minus 4ac. And we can use just this to find out whether our quadratic will have two distinct roots, two equal roots, or no real solutions. So I'm now going to go through the rules of using the discriminant, and this is really important that you learn these three key points so that you can use them in an exam. So the first rule states that if b squared minus 4ac is greater than 0, there will be two distinct real roots. So what this means is if when we substitute our values of a, b and c into the discriminant, we get a value greater than 0, then we're going to get 2 points where the graph will cross the x-axis, two distinct real roots. So for example, it could look something like this, where we have a root of maybe 1 and 3, 1, 0, 3, 0, okay? Two distinct real roots. The second rule is if b squared minus 4ac is equal to 0, then there will be two equal roots. What this means is if we substitute in our a, b and c values, we get a value equal to 0, then the graph will touch the x-axis at exactly 1 point. In this case it could be 3, 0. But it will touch that point to give two equal roots. And the last rule is if b squared minus 4ac is smaller than 0, then if you remember back, that's the part we're square rooting. So if that's less than 0, then we're going to get the square root of a minus number. Now, we can't square root a minus number without getting a complex number. And for core 1, we're not expected to know anything about complex numbers. Therefore, we just say there will be no real solutions. And there won't be any real solutions. However, there will be maybe imaginary solutions. Again, that's part of another course that I may touch on later on in the videos. But for now we just say if the discriminant is less than 0, there are no real solutions. So let's move on to the first example, which says find the discriminant of 15 minus x minus 2x squared and state the number of roots it will have, if any. Okay, this is part A of a question. I've taken this from the AQA textbook, and this is a question from that. However, I've extended it to make up a part B. So we'll go through this as an extension to our lesson on completing the square. For now, let's look at this question. Now, the first thing we have to do is quote the discriminant to show we know what we're doing. Okay, we're substituting our values into here. Now, looking back to our last lesson, the coefficient of x squared, in this case it's minus 2, is our a value. The coefficient of our x, in this case minus 1, is our b value, and this is our c value. So with b squared minus 4ac, we get minus 1, our coefficient of x squared, minus 4 multiplied by a, which is minus 2, multiplied by c, which is 15. Now minus 1 squared, that's positive 1, minus, and we're going to get 4 multiplied by 15 is 60, multiplied by minus 2 is minus 120. 1 minus minus 120, remember the double negative is going to give us a positive value. 1 minus minus 120 is just 1 plus 120, that's 121. And the last thing to do to get the final mark is to state the point, referring back to our key points from the lesson. Now, as 121 is greater than 0, if we look back here, if b squared minus 4ac is greater than 0, there will be two distinct real roots. So we say as 121 is greater than 0, there are two distinct real roots. Okay, and that's our answer. We have to make this point to get the final mark. If this value we calculated happened to be, I don't know, minus 10, then our discriminant will be less than 0, so we'd refer to this point. There will be no real solutions. You just state the line appropriate for the question that you're given. But that's why you need to remember all of these possible outcomes. You need to learn these. Now this is the part B to that question. I've made this up, this isn't from the textbook, but it could easily be a valid question they could give you. However, this is slightly more harder than I would expect an exam would give you, because we're having to complete the square with a very difficult quadratic. But it can be done, so let's go through this, okay? You can have a go yourself if you want, pause the video and have a go. But the question says, find the vertex and sketch the function from part A. So to find the vertex, all this means is find the maximum or minimum point of the quadratic. And we do this by completing the square of this function. A key point we're going to have to remember when we do this is that the coefficient of x squared in this example is -2. It's a negative. Now hopefully we know if a parabola has a positive coefficient of x squared, then we're going to get something like this, a U-shaped graph, where we're going to have a minimum point only. However, if we get a negative coefficient of x squared, like here, we're going to get a graph that might look something like that, where we're going to have an n-shaped graph with a maximum point. Okay? So if it's negative, we get an n-shaped parabola, and if we get a positive coefficient of x squared, we're going to get a U-shaped parabola. So let's start answering this question. The first thing we do is we complete the square. Now if the coefficient of x squared is greater than 1, we have to take this factor outside the bracket. In this case it's -2. And we multiply that by x. Now remember, whenever we complete the square, looking back to my previous video, lesson 2, if you want to go back and check, we halve the value of b and put that inside the brackets. However, here we're taking out a factor of 2 also, so we're having to halve our value of the coefficient of x, which is -1, and then we're having to halve it again, take out another factor of 2. So if we halve -1, we get -0.5, and if we halve -0.5, we get -0.25, which is a quarter. Now remember, this is actually going to be a positive inside the brackets, because when we multiply this positive by our -2, we're going to get -1 when this is squared, okay? And then we subtract or add the value we calculate when we square the quarter and multiply it by -2, and then we add our value on the end, in this case the 15, the c. So let's go back to how we complete the square. We now have to multiply the quarter by itself. We square this value. So a quarter multiplied by a quarter will give us 1/16. We then multiply a 16th by the value outside of the brackets. We start by dealing with the squared using BIDMAS, then we multiply by -2, which we can think of just being -2/1, so we can easily multiply these fractions, and we get -2/16, which equals an eighth. Okay, -1/8, it's negative, -1/8. So, we have -1/8. Now remember, if this is a negative, which it is, we then have to add this on. Thinking back, we do the opposite of whatever answer we obtain. If we were to get a +1/8, then we would have minus this from this function. We would have done -1/8. But here we've obtained a negative answer, so we add it on. Now we can just simplify this. So we're doing +1/8 plus 15. So if we're going to add 15 on, then it will be better to make the 15 out of 8 also, so that we can easily add the fractions. Well, if we think of 15 as being 15/1, then that's the same thing as 120 over 15. Because 120 divided by 15 gives us... 120 divided by 8. Because 120 divided by 8 will give us 15. So 15 can be changed into this. And then we can simply add the fractions to get 121 divided by 8. So there's our answer. Minus 2, open brackets, x plus a quarter squared, plus 121 divided by 8. So, how do we find the vertex from the point we're given here? Well, the vertex of the graph is going to be the inverse of what we have here. If you think back to transformations of curves, if a value inside the brackets is a positive, then that will actually mean it moves left by that value. And if it's negative, it would move right by that value. So the vertex of this curve is simply minus a quarter. We take the negative of what is inside the brackets. If this was minus a quarter, it would become positive a quarter. And then the y-coordinate of our vertex, in this case a maximum point, is the value outside the bracket. And this just stays the same. This remains positive. The sign here does not change, however the sign inside the bracket for the x value will change. So that's very important you remember that. That is the vertex of the curve. And this value here is 15.125, but we'll leave it in this form. Once again, it's a Core 1 exam, you won't be expected to be able to turn this into a decimal. Okay? So that is the answer to the question. We found the vertex by completing the square, taking the negative of what we had inside the brackets, and using the sign that is the same for the y value outside the brackets. So that's the vertex of our curve. And we could state that this is going to be a maximum point. We don't have to here, but we could just state that. Because we have a negative coefficient of x squared, so it's going to be an n-shaped graph. Therefore, the vertex is going to be at the top, a maximum point. So thanks a lot, guys. That's a lesson 4 on the discriminant. In the next lesson of quadratics, we'll be looking at quadratic inequalities and how we can use them to find the points where a graph is increasing or where it is decreasing and converging towards a vertex. I'll show you exactly what we mean in the next lesson, but that's it for now. If you found that video helpful, please subscribe to my channel, please like the video. If you do have any comments, feel free to ask and I'll get back to you as soon as I can. Thanks a lot, guys, and I'll see you in lesson 5.